Welcome back. The problem is that so given the stoichiometric ratio of oxygen and hemoglobin and the mass of hemoglobin, volume of oxygen, the temperature and pressure, can we find the molar mass of hemoglobin? So in the stoichiometric ratio of hemoglobin to oxygen is 1:4. Secondly, now we will find the number of moles of oxygen. Once we find the number of moles of oxygen, by using this stoichiometric ratio, we will find the number of moles of hemoglobin actually taking part in that reaction. And from those number of moles, we will find the molar mass of hemoglobin. So first we'll find the number of moles of oxygen. So we use formula PV is equal to nRT. This is the ideal gas equation. P is the pressure, V is the volume, N is number of moles, R is the gas constant, and T is the absolute temperature. Now let us see what are the units of gas constant R. We are going to have the value of gas constant at 0.0821 and the units are liter, atmosphere, mole, and K. K is the absolute temperature in Kelvin. So we shall convert these units. So first we have been given the pressure in torr, and the pressure is converting torr to atmosphere, we get 743 torr is equal to 0.977 atmosphere. Second parameter which we are going to convert is volume. Volume has been given in ml, and that is ml is converted to liter because we are going to use value of gas constant wherein the units are in liter. And the third unit to be converted is temperature from Celsius to Kelvin. So we got the temperature at 310 Kelvin. Substituting these values in PV and RT, we get the equation like this, and further simplifying we'll get number of moles equal to 5.87 into 10 raised to minus 5. Now using the stoichiometric ratio, we can find the number of moles of hemoglobin from these number of moles of oxygen. So the stoichiometric ratio we have been given is hemoglobin, number of moles of hemoglobin as to number of moles of oxygen, it's equal to 1:4. And in this case, number of moles of oxygen are given, that is 5.87 into 10 raised to minus 5. Therefore, number of moles of hemoglobin taking part in this reaction, that equals to 5.87 into 10 raised to minus 5 divided by 4. And so we get the answer, number of moles of hemoglobin taking part in this reaction, 1.46 into 10 raised to minus 5. So now the next step is to find the molar mass of hemoglobin from its number of moles, and the formula is molar mass is equal to mass in grams divided by the number of moles. Substituting the values, we get the mass is given 1 gram and number of moles is 1.467 into 10 raised to minus 5. So the answer we get is 6814. So this is the molar mass and that is the answer. Thank you.